Okay, thanks everyone for coming out. So today we're going to talk about the Universal Registry contract. This is something that's been in discussion for many months, and then really last week during the sequencing week, it started to actually take some shape. And there's still a lot to explore, a lot to discuss, and hopefully this is going to be kind of a milestone for pushing the conversation forward and getting more teams on board. So the overview of this talk is really going to motivate, like, why do we really need this thing? A lot of the teams here are focusing on based sequencing, pre-confirmations. So maybe this first part I'll try and go through a little quickly. It might be a little redundant because we're all trying to build for the same reasons here. So yeah, why are we here? So a lot of us share these same values. A lot of them, what brought us into Ethereum in the first place. We care about censorship resistance, permissionlessness, decentralization, and we really want to build this positive sum ecosystem. So building based rollups and pre-confirmations is moving in this same direction. Maybe for other reasons, though, it's really nice to focus on because we have this opportunity to really build something competitive that can drive forward the Ethereum narrative and allow us to compete with some of these alt L1s. So how did we get here? Well, the goalposts are always moving. Gas was too expensive, so we started this rollup-centric roadmap. We offloaded all this execution to the L2s and accomplished our goals. Things got cheaper, TPS increased, but now ETH is dead all of a sudden. So can we really do anything to solve this last problem? So first of all, like, why is this happening? Lots of reasons here, but really the focus of this talk is on fragmentation. So currently, L2s don't really interoperate with each other. And this causes fragmented liquidity. You have DEXs spread across over 100 different L2s now. This fragments user bases. Developers have a hard time because they have to pick a winning chain to deploy their dApp. You can always hedge by going across many, but of course this spreads your resources pretty thin. And in terms of ETH, like, DA fees right now are pretty low. Execution was where most of the fees were generated, and we offloaded that, and causing issuance to increase. So another point here is I think what we're starting to see is this shift towards what I'm calling intra-op. We'll have interoperability within our closed roll-up ecosystems. And what we want to work towards is true interoperability, where we shift from this negative sum game back to this positive sum. So really the problem is we need to solve fragmentation. And how can we do that? Well, one of the easiest things we could do is we can just agree to have one person sequence everything. That's it. Everything will interoperate, but getting there without it becoming completely centralized is really the big challenge. So this is where based rollups start to come into play. What is a based rollup? Justin describes it as really a rollup where the sequencing happens by Ethereum validators. And this could be in conjunction with the current block building supply chain that we have today. So in practice, what does this kind of transition look like if we're trying to work towards base sequencing and allow for more interoperability? On the left-hand side, this is where we're at today. Centralized sequencers will take all these unordered rollup transactions and produce this nice ordered sequence for these squiggly rollups at the bottom here. So shared sequencing is a shift towards decentralization. We have a committee of different sequencers. You have some kind of leader election mechanism, and they get to have exclusive rights to sequence the set of rollups. And as we move towards this full base sequencing model, the idea is we want Ethereum validators to play this role of the sequencers and allow them to sequence a whole plethora of based rollups and in the future based app chains. So how does this really enable? Like, how does base sequencing actually help here? The idea is around state lock. So today, when a validator proposes a block, they have this monopoly. They get to decide the full sequence of L1 transactions. When we, and this is the same right now for a centralized sequencer. Like your standard rollup today, there's a monopoly on how they sequence the rollup transactions. When we start to have shared sequencing, where one person is responsible for sequencing multiple rollups, this is where you're able to start to give better guarantees to users. Like I can guarantee sending a transaction on rollup 1 and another transaction on rollup 2 and have them interoperate because I actually have the monopoly over both of the rollups at that block. So base sequencing is the same idea of shared sequencing, just maximally credibly neutral. And we want to enter this world in the future where like maybe we have the superchain, we have Arbitrum, we have all of these different ecosystems. But if we're relying on shared sequencing, it's going to be hard to find that neutral party that can sequence both of these. And so the natural, credibly neutral source would be the Ethereum validators. So based rollups come with their limitations. Primarily, it is around bad UX. So currently, to sequence like a based rollup, you have to wait 12 seconds for the L1 block times. We can always fix this if we hard forked Ethereum, lowered the block times, but that introduces a whole lot of centralization vectors, could introduce client bugs, and put more pressures on the Ethereum validators. So this is where pre-confirmations as a concept come into play. They're a way for us to solve this bad UX problem without modifying the base layer. So what is a preconf? It's really just a commitment from the proposer to a user about something. So typically the example would be inclusion. So an inclusion preconf means I guarantee that I'll include your transaction when it's my turn to propose the block, and if I don't, you can slash me. So it's this economic guarantee. A better promise would be, I will execute your transaction with this final output state, and when it comes time to propose the block, if you get a different output state, you can slash me. And so these latter ones, these execution preconfs, are really how we start to get those like 100 millisecond transactions competitive with these alt L1s. So how does this look in practice? So the first thing would be an Ethereum validator in the middle here can opt in to make this credible commitment. Like I will be a preconfer. Then when a user wants to send a transaction, the validator is going to promise to include the transaction or promise to execute it depending on the specific protocol. And then they'll finally propose the block. And if they messed up in any kind of way, this user is able to slash the validator. This holds them accountable, right? Okay, so how do we get there? Well, this whole world of preconfs and based rollups solves a lot of these issues of fragmentation. But if we really want to arrive at this end destination, we need standardization so we don't enter some other pathway that, like of centralization, fragmentation amongst different preconf protocols, different based rollups. And so in this effort, standardization amongst sidecars is important. There's efforts like Commit Boost to build very neutral sidecars. On the APIs, this was pretty big from last week at Sequencing Week. Lots of teams were coming together to try and agree on these specs and APIs for how the supply chain will look. And the focus for the rest of this talk is on the pre-conf registrations, having a neutral ground for all of these different validators to opt in and for these different pre-conf protocols to discover these validators. So what is this universal registry contract? It has two primary functions. We need a place for validators to register for proposer commitments. And a proposer commitment is just more of a general form, like pre-confirmation is a commitment made by a proposer. So this registry contract will be able to support arbitrary of these types of commitments. And then the contract needs to be able to slash these pre-confers that break these commitments. And there's a lot of properties that we would want for this universal contract. Like the primary thing is that it should be neutral. It should be immutable. We don't want to rely on any kind of governance. It should be maximally expressive to support future use cases of proposer commitments and for people to build on top of it. We should use ETH as collateral to remain credibly neutral in terms of the type of capital. And some of the goals here are to minimize switching costs. We want a new pre-conf protocol to be able to come to market and users, like these validators, to be able to seamlessly switch between them to avoid some of these monopolies. minimize dependencies. This comes down to like restaking platforms. We shouldn't enshrine anything specific around slashing there. We should allow for the contract to be as expressive as possible and minimize these dependencies. And of course, it needs to be gas efficient or no one is going to use this thing. So there's been some guiding lights here. Justin had kind of laid out some of the goals here of like what we would want in this contract. Some I had just covered. But also there's different teams that have been building this. So today Puffer has an AVS on EigenLayer. There's the Bolt team, Chainbound, and Tycho has been working with Nethermind on their own registry, and Spire has been pushing out research around this registry as well. So coming into sequencing week, there was a lot to start from. So some motivation here is like, what do we want to avoid happening? Like, this is motivation for why we would want this kind of contract. So in step one, like this is in the future without the registry, a user or one of these validators would want to register at Tycho Preconf AVS, for example. And maybe they decide they want to unregister and join at a different protocol, like Unifi. In this case, every one of these steps costs gas. It increases friction and starts to introduce vendor lock-in. It also, on the right-hand side here, makes it incredibly hard for these different consumers of the registry to operate. So for example, we have your wallets will all need to know which of these validators are opted in for pre-confirmation so that your wallet can then give the user these options. We have different gateways. These kind of operators within the Preconf ecosystem need to be able to discover these different validators that are opted in. So you can imagine, like right now, there's only a couple of things out there. If this grows out of control, it'll be kind of a logistical nightmare for everyone. And so what we would prefer is to have this central location, this neutral universal registry contract, where a validator can just register, and whenever they want to make a commitment that they're going to like operate for someone's Preconf protocol, they would just sign an off-chain commitment message that doesn't cost anything. So we've moved from this world of like gas every time you want to change to now just one-time registration and seamless switching between these protocols on the fly. So in building this registry, there were a handful of design decisions. We wanted to first make sure that people will use this. A lot of the naive implementations would be so gas prohibitive that no one would really opt into this thing and it would defeat the purpose. So minimizing storage was one of the first decisions. The idea being we need to know who all the validators are that are registered. The naive thing would be to store all of your validator public keys in the contract, and looking this up, or like storing this costs a lot of money. So the first design decision here is during registration, a validator is going to commit a bunch of these registration signatures and Merkleize it all into this operator commitment hash, and just save that on chain. So we've kind of reduced storage costs from this linearly growing thing into just 2 storage slots per operator. And you can amortize that cost over hundreds of validators potentially. Another design decision here was around minimizing gas, not related to storage, but from execution. So in order to know that a validator actually registered for this contract, you would want to make sure that their signature is valid. And that requires BLS signature verification on chain. And even though in this upcoming Pectra hard fork, we're getting BLS precompiles, it will still actually be cost prohibitive to do this directly on chain. And so the idea here is, can we optimistically register and then allow anyone to actually produce a fraud proof that says, hey, this guy doesn't actually own this validator key because the signature is valid. I can slash them and claim some of their collateral. So this is another design decision that's really meant to reduce any friction for validators trying to join this system. And the third design decision is around slashing. So in Justin's original proposal, there was this really elegant idea of having a validator commit to some bytecode. And this bytecode represents all of the slashing logic to be executed should they break their promise. There were some issues, mostly around like deployment costs. Like you have to deploy the bytecode and then execute it. This is maybe a minor detail in terms of efficiency, but I think the big thing that this approach really limited were stateful slashing. The idea is there are going to be cases, like people are going to design these pre-confirmation protocols where the slashing condition is actually another one of these fraud proofs. And if you do it this bytecode way, you kind of cut off that option. So what we move towards is this stateful approach. So when a validator commits to running some kind of pre-conf protocol, they're signing off on some slashing contract that exists. And this could be audited, verified, deployed code. And what this enables is we support these fraud proofs, but we also support existing slashing infrastructure. So potentially you could be opting in and your slashing contract could be pointing to your favorite restaking protocol, the EigenLayer or Symbiotic, or something custom you built yourself. Right, so how do we put this all together now? Like what is the flow for a validator using this universal registry contract? So step one, they would do this registration, this optimistic registration pattern. And once the fraud proof window passes, they would sign off on these off-chain commitments. So a lot of this caveat is still a work in progress as the specs are being finalized, but kind of rough consensus from sequencing week was that they would sign off on these delegation messages using their validator keys to remain as compatible with the existing PBS supply chain. So this signature is saying, I allow this delegate public key to issue pre-comps on my behalf, and that key could be their own key, it could be someone else's, like a gateway. So this signature will be broadcasted throughout this network, so wallets will know which validators are committed and like kind of which slot they're operating under. And then a user should be able to ask, like send a transaction to get pre-comped. So in this picture, we show a gateway, but this gateway could also just be the validator themselves. It's really optional in that case. But in exchange, the user would get this pre-confirmation signature, and that is what would be used later if there were ever broken commitments. So in that case, you can take this pre-conf signature, some evidence, and submit it back to the URC and get this pre-confer slashed. And so this is, again, like adding accountability, this economic security to ensure that the pre-confer is doing what they're saying. So this was the result of a lot of teams collaborating. Primarily on the URC team was a collaboration between Puffer, Lido, Nethermind, and Spire. But lots and lots of feedback from all the people in this photo throughout sequencing week as well. And so there was a lot of progress this week. Before, there were multiple implementations of registries kind of on testnet or on mainnet. And kind of at the start of sequencing week on Tuesday, most of the discussion was around, do we actually need this thing? And by Friday, we had a nearly complete implementation. And so there's definitely, we hit some milestones, and I think we're kind of entering the hardest part of this challenge is convincing everyone in the audience to continue on in this effort and so that we can reach standardization, reach rough consensus on exactly what needs to be implemented. And with that, thank you so much.